Good afternoon, everybody. Welcome back to the HCSP training course. So this afternoon, we will continue with the rest of the contents, which is the VPN part. First of all, let's have a look at the basic concept of the VPN and also the commonly used VPN. Currently, the Houston StoneOS system support those VPN types or VPN scenarios, including the IPsec VPN, the SSL VPN, which is the SC VPN in our system, and also L2TP VPN for the remote users over IPsec, and also the GRE VPN. For the IPsec VPN instance, we can use the IPsec protocol to support for different user scenarios, including the site-to-site IPsec, the dynamic IPsec VPN, the hub-spoke, redundant VPN, the die-up IPsec, the plug-and-play VPN, and overlapping address for the VPN scenario, XNorth, and also the IKEv2 IPsec. All those can be supported in the Houston NG firewall. Let's have a look at the basic IPsec protocol. Some of you may have the basic understanding or experience regarding the IPsec, which is the Internet Protocol Security. IPsec is the widely used protocol suite that especially for establishing the VPN tunnel. IPsec is not just a single protocol, but a protocol suite for securing the IP communications. It includes the authentication headers, which is the AH, the encapsulating security payload, the ESP, the IKE, which is Internet Key Exchange, and also some authentication methods or encryption algorithms. The IPsec protocol helped to define how to choose those security protocols and also algorithms, the way for the key exchange between both sides. It will offer the up-layer protocols with the network security service, including access control, data authentication, and also encryption features. The Security Association is also important base and essence for the IPsec, which defines the factors of the communication pair, including the protocols, the operational modes, the encryption algorithm, and the shared key for the data protection. SA is marked by the three tuples, including the security parameter index, which is the SPI, the destination IP address, and also the security protocol number. This is the three key elements of the VPN we already mentioned during the HCSA call: the confidentiality, integrity, and authentication. For the ESP, which is the encapsulating security payload, it using the protocol number 50, which help to provide the data confidentiality, the data integrity, and also data source verification, which also covered all those three key elements. It can be used in both tunnel or transport mode in the VPN. Here is the ESP packet under the tunnel mode. As you can see here, the ESP header was added between the new IP header and also the original IP header. The ESP header includes the port number of the ESP, which is 50, and security parameter index and the sequence. It will it will include or it will provide the both encryption and authentication for the original IP packets. That is the ESP. Another one is authentication header, which using protocol 51 to provide the data integrity, the data source verification. In this case, comparing with the ESP, the AH will not offer the data encryption service. In this case, it will not encrypt for the original data. It can also be used in both tunnel and transport mode. Here is the example for the AH packet. The AH header also added between the new IP header and the original IP header. The AH header including the port number, the protocol number 51. The next header and also the payload length, the security parameter index, and the sequence. As I mentioned, it will not offer the encryption service by only using the authentication for the original packet. So that is AH. So comparing with the ESP, so ESP will be more secure in this data encryption. IPsec protocol has two encapsulation mode. One is we call transfer mode, another is tunnel mode. Here's the original packet. So the original data, we will add an IP header to transfer the packet in the internet. When you are using the transfer mode, we will add the IPsec header between the IP header and the original data. And in tunnel mode, we will add a new IP header together with the IPsec packet to develop the comprehensive security service for the original data So transport mode more or less used in the scenario for the host to host or host to gateway connection, VPN connection. And tunnel mode widely used for the site to site or gateway to gateway VPN connection. For the VPN currently, there are two versions of the IKE, which is IKE v1 and IKE v2. IKE v1 that use two phases to negotiate for the IPsec key and also create the IPsec SA. So the phase one, both sides will negotiate and create the secure tunnel for the IKE itself. And phase two will use this authorized and protected secure channel to create the IPsec SA. And the IKE version 2, which simplifies this negotiation process, that IPsec key will be generated directly at the first time negotiation and then create the IPsec SA. So that is the difference comparing with the original IKE v1 and IKE v2. Here is the three IKE mode for both phase one and phase two. So in phase one, the ICKMP SA, there are two modes. One is Mem Mode, another is aggressive mode. So Mem Mode, we use 6 messages for the negotiation, and aggressive mode only need 3 messages. And in phase 2, as we mentioned before, there's only one mode, which is the quick mode. This slide gives you some idea of the difference between the Mem mode and aggressive mode. Under the IKEv1 assay, which will have two negotiation mode, the Mem mode and aggressive mode. So Mem mode includes the three bidirectional exchanges that using 6 messages. So the message 1 and 2 used for the algorithm negotiation, and message 3 and 4 will be used for the key exchange and also the DH algorithm. And the last 2 messages will be used for the identity and authentication information exchange. If you are using aggressive mode, which only use 3 messages, the message 1 and 2 were used for the proposal negotiation, including all these authentication, algorithm, encryption, etc. And the message 3 used by the responder side to authenticate the initiator. So that is the difference between Mem mode and aggressive mode. Based on the packet, you will also see the difference for the Mem mode and aggressive mode. So the first one, this is the Mem mode. Under the Mem mode, we capture the packet. As you can see, we use 6 messages. We use 6 messages for the negotiation, for Mem mode. And for the quick mode, aggressive, we only use 3 messages. IK key exchange. The Ipsec VPN use those negotiation to generate the key and protect the data secure transmission, which including the identity authentication, the identity protection, the Diffie-Hellman key exchange, or the key agreement algorithm. And last one is the PFS, the perfect for security. For the identity authentication, which used to confirm the identities of both sides during the communication by authenticate through the pressure key or digital certificate, digital signature, which including IC or DSA, IC signature or DSA signature. And the negotiation mechanism at both channels must be consistent. So we need to use same DH group. Currently, we support those types of the DH group with different key lengths. The group 2 is the default. It's the default one that we used for the Ipsec. And only phase 2 will use the group 0, which is no PFS. As you can see, this is the phase 1. And for the DH key exchange, both sides, the devices will generate a key pair. So both sides will generate a key pair, and then they will exchange the public key. After that, the local at each device, they will combine their local private key with the peer public key together to form a session key. That is the key exchange. For the PFS, the perfect for security, which is a short one-time key system. So it will ensure no matter what phase is in, so only one key will be used for one time. And the element used to generate this key will be only used for once. and it will be discarded after generating a key and will never be reused for generating another key. So in this case, it will assure even a single key is disclosed. The disclosure will only affect the data that is encrypted by using this key, and it will not threaten the entire communication. This PFS is based on the DH algorithm, and implemented by re-exchanging the DH at the IPsec SA phase. Here is the configuration for the PFS group. So we support those 6 group for the PFS service. So no PFS is for group 0, So what are the advanced settings in the IPsec? Let's have a look. The first one is we called net transversal. The IPsec virtual private network clients use this net transversal in order to have the encapsulating secure payload packets traverse the net if the net functions is in use between both VPN sites. If we use in this scenario, we must enable the transversal in the firewalls. As you can see from this packet structure, the Internet Key Exchange, the IKE, which is the UDP port 500, and the encapsulating secure payload, which is ESP, we use the protocol number 50, the AH protocol 51, and for the transversal, we use the UDP port 5500 if the net transversal is enabled in the firewall. So we will add the UDP port 4500 to support the IPsec net transversal. So this function is used when there is any net devices or net functions that in use between both sides. And another one is Proxy Id. Proxy Id is used during the phase 2 for the IKE VPN negotiations. Normally, the proxy ID will be the LAN address entry for both sides. Both sides you need to manually set for the proxy ID, or you can simplify use the compilation of the source IP, destination IP, or service in the tunnel policy to control for the communication. So if you are using the root-based VPN, it's better to manually set for a proxy ID between both sides for the access control. Sometimes if you set incorrect proxy ID at both IPsec VPN instant, it will cause the mismatch of the proxy ID. Proxy ID, and also the VPN connection will not be established successfully. So that is called proxy ID. We also support to add multiple subnets into the proxy ID list. If you have multiple subnets in the organization, you can add multiple address entry into the proxy ID list. And in the IKE phase 1, we also support for some advanced settings. One important feature is the DPD, which is the dead peer detection. This feature is used to detect the status of the secure tunnel peer status. When the responder does not receive any peer packets for a long period, we can enable this DPD and initiate the DPD request to a peer to detect if the gateway still valid. By default, this function is disabled. We highly recommended the customer to enable these functions to detect the status of the secure tunnel. There are also some other advanced settings in IKE phase 2. You can set for the BF bit, the anti-replay or commute bit, or accept all proxy ID. If you have multiple proxy ID, you need to enable this accept all proxy ID. And auto connect. Normally, we need to enable the auto connect to automatically trigger the negotiation packets or the connections between both sides without manually triggering with the traffic. So these are the additional information for the VPN, especially for the IPsec VPN protocol.